Hi, y'all. I'm Rainu. Thank you for the warm welcome. I'm from Nashville, so wooing is very much a part of the Broadway culture I'm used to. So that makes me feel right at home. I also want to go ahead and start by saying thank you to our organizers and all the volunteers and all the work that they're doing. I know that it's sincerely like a labor of love, and I have so much empathy and love and respect for those folks, so thank y'all for that. Yeah, 100%. So this is a talk that I've called Data Engineering the World Between Worlds. I altered my slides just a little bit based on our keynote this morning, because truly, like, this has been my journey into the world of data engineering over the course of the past 5 or 6 years. And so I can go ahead and start by introducing who I am. So I currently work as a staff engineer of systems at Jack Henry. I have a bunch of hobbies. These are things I do outside of code. I do powerlifting, weightlifting, CrossFit, cocktails, cooking. If you ever want to chat with me about any of those things, like, I can definitely nerd out about all of these. Also dogs, not the Georgia dogs, but my dogs. I love them deeply. I'm definitely a dog person. If you're looking for me, the best place to contact me or reach out would be on Mastodon, and my handle is Rainu Itty. So we're talking about this journey, right? Fun facts, I was an English major, so there's gonna be a lot of like little allusions to various fiction works and pieces of fiction that have kind of played into how I've mapped out the world of data engineering in my mind. And so this is a quote from Lord of the Rings. "The road goes ever and ever on from door to door where it began. Now far ahead the road has gone and I must follow if I can." If I can has been the question for me along the way. So we talked about being an English major. Here's English major me, graduating from Belmont in Nashville, not knowing what was ever going to be ahead of me. I thought that I wanted to go to law school. I thought about going to grad school. Thought about all these paths, 2 or 3 years, and a panic attack later decided that is not the path. And instead, I went to a web boot camp called Nashville Software School, where I learned about the worlds of front-end and back-end engineering and generally API design and a little bit of like what goes into understanding SQL and CSS and that whole full stack kind of mindset around application engineering. And so, oh yeah, I am an English major. So by the time that I left the boot camp, the world that I understood was sort of this, right? Okay, here's a front end, here's a back end, and the user looks at the front end, and generally speaking, the back end's pretty gnarly, so, just bear that in mind. And the person who mentored me at the time was an amazing front-end engineer, and I assumed that would be a great path for me because it had been for him. And so I started out doing various parts of this across the stack, whether that was like building front-end metadata or dealing in JavaScript or dealing with CSS or the backing APIs for some of the things I was doing. And the only artifact that I cared about or really like knew about at that point in my career were the business models, artifacts that lived in that relational data store that backed the application. So those were things like Postgres, MySQL, SQL Server, that kind of stuff. And slowly but surely, like I got more curious. The road went on, and I decided it might be interesting to continue on. And so I started working on SEO engineering when I was at another organization, and I learned more about other artifacts that existed. So that was third-party marketing data, third-party data that we were integrating into our analyses of how users were interacting with us. And then also like the user clickstream data, whether that came through Google Analytics or other streaming tools. I had a sense that I cared about that and cared about what was going on with it. And sort of the part where I noticed more within data engineering was when I went to write a SEO experimentation framework to measure how our users were interacting with the various changes that we made. And so I think a lot about this quote from Neil Gaiman. This book, Neverwhere, is amazing. In that book, there's this London underground, the subway system of London, that has a whole world between the cracks, and there's monsters and fantasy, and it's quite amazing. I highly recommend the book. It's lovely. And I felt like when I got into data engineering, I had just fallen into this fantasy world of a whole new kind of complexity and set of systems that, to me, had been invisible until then. And so this quote is, "Young man, understand this. There are two Londons. There's London above, there's where you lived," application context in this case, and then there's London below, the underside inhabited by the people who fell through the cracks in the world, and now you're one of them. Good night. So I went from this understanding of one ring to rule them all and a single RDBMS to hold all the artifacts that I might care about to all the things. And so this is where my story dovetails with the story of data and where we are as an industry right now. Back in the 60s, they also had this sense that there was one RDBMS to hold all the artifacts. And your analytical queries and these heavy things that you were doing to analyze user behavior were all happening against that same database. And in this terminology, we call that your online transactional processing database, which was making for not great user interactions from time to time, because you're actively slowing down the transactions that help you make money due to transactions where you're trying to internally figure out what's happening. So the answer, the very first data warehouses were at literal separate buildings from the initial data warehouse, and we came up with this concept of online analytical processing, which is when we took that same context and ported it over into databases that were better tailored for the types of analyses we were doing. And in the modern context, these are things like Athena from AWS or BigQuery from GCP's suite. You've got Postgres, or sorry, not Postgres, Presto, others like columnar data stores that are built for doing these heavy queries by themselves, not necessarily just transacting across them. So the data engineer in this case is really the guy straddling the two trucks. He's dealing with porting that context from the live OLTP to online analytical processing. And so this expands our context to not just those user artifacts, but what we create within the data warehouse, what becomes useful for those folks who are maybe analysts or data scientists, machine learning folks. And then machine learning folks in particular have all these other models that are creating outputs that need to go back and interact with those users. And so those are also now becoming their separate own entity and where we persist them. However, we're really focused here on more of the data warehouse and everything that goes into creating a meaningful data warehouse. So when I say that I fell into the cracks, this is more of what I'm meaning. Everything over from like the red and the green didn't really exist in the first context in which I had come into tech. I didn't even know that these things were a part of the world that someone might care about. And for me, data engineers are the folks who are pushing all of those lines through those various contexts, because each of these artifacts in and of themselves don't really tell the full story of how your user is interacting, how impactful your product is, or how delightful the experiences on that platform might be. Being able to gain a sense for that requires contextualizing all of them against each other with the customization of your business model. And that is the real, without impacting your users, and that is the real value of having a data warehouse and data platform. So there's a few various archetypes of data engineering that end up being the folks to do this type of work. And I'll go ahead and throw out the disclaimer that certainly all of this is evolving and changing with the times and as needs and platforms change. But I've gotten a chance to live a lot of different lives across this architecture, and I want to talk a bit about some different patterns of folks who contribute to this, and if you want to learn to do data engineering, potentially some of the tools that you might run across or want to learn. So we'll start with the progenitor of all of these various archetypes. The database administrator, or the DBA, they are primarily folks who care about what's happening to your OLTP database. They care about the fact that those transactions are high velocity, good quality, and that we're designing the database model from the application in a sane and scalable way. And these folks have a deep expertise of Postgres, of MySQL, of RDBMS frameworks, and sometimes also like the ORMs, or object relational modeling, that is querying from the application. So these folks start out at the very beginning of that chain of ingestion and are like a key player in talking with dev and engineering teams about how to sanely design your data model. So here's the first flavor of data engineering. Most folks start here, which is ingestion, right? So all of these initial arrows of like pulling in data from all of these different places. And this is by no means comprehensive. You can have as many contexts and APIs as your business needs to pull into that data warehouse. And so their business value proposition fundamentally is contextualization of that data. And they are usually doing some amount of orchestration of the extract, transform, and load pipelines into an OLAP store. And that orchestration can take place in a number of different possible frameworks. There's a deep SQL knowledge here, as well as general automation and a bit of software engineering as well, because they deal in various products that are closer to the engineers and to the application. If we can speak the same language, we might be able to come to a conclusion on potentially like how we're affecting each other with those artifacts. So some example tools that you might want to learn if you're interested in doing this type of data engineering are PySpark. It's a distributed processing engine. It's actually a wrapper around Java, and that wrapper around Java is a wrapper around Scala. Depending on where things like regexes are being executed, you could run into various syntaxes for them. It is a heavily leveraged tool. Definitely would learn that as part of ingestion. Also, in general, data build tool, or DBT, is heavily leveraged for doing at least some minor transformations and pulling in some of that data as it comes through. As far as an orchestration layer goes, the most popular one by a long shot is Airflow, still, from my understanding. But there are others coming as well: Dagster, Prefect, Luigi. Some folks are still using crontab as well, depending on the maturity of their data engineering program. Airflow, in particular, is Python all the way through. I haven't worked as much with Dagster or Prefect, but I know for Luigi and Airflow, those have contexts in Python that make it really valuable to write your own Python operators or sensors or other components that if you don't have a basis of understanding in Python, you won't be able to extend their framework in a way that makes sense for your business. Secondly, this is another flavor of data engineer. Once you get all that data in place, we want to be able to do things with it that are valuable for the business. And a lot of times, there's so many asks that being able to just use your data engineering team to help with every single one of those asks that's coming back out of the data warehouse is really tough. And in order to scale some of those requests, you're better off to build the tooling to self-service whatever needs you might have for folks to do analyses, export, and ultimately like serve up results into the application. And so that can take a few different forms. Sometimes you're pushing into an ML platform, which then the data scientists are leveraging so that they can do all of the very complex math that ends up being surfaced back in the application as recommendation engines. Or folks have also gone as far as to build a separate microservice to sit on top of the data platform and then serve up results into some other type of data store. So they'll export various analyses into things like Elasticsearch or Redis, or sometimes even Postgres or other RDBMS, so that your application can then call those APIs and pull back some of those complex results without taxing the OLAP system directly, so that you maintain this idea that the OLAP system is separate from the OLTP to gain that benefit. So the goal of this type of data engineer is to build tooling and infrastructure to make the data platform more usable for non-data folks. And so that takes a whole range of skills, cloud infrastructure, DevOps, at least a basic understanding of data model deployment pipelines, and API design if you're putting up a data access layer, just general distributed systems familiarity, and also a variety of data stores depending on what your use case is within the application. So a few example tools and frameworks that will be useful if you wanted to get into this type of data engineering. Cloud infrastructure familiarity. Depending on your business, that can mean many different things. Just knowing what is available to you, and then also Terraform or some other infrastructure as code so that you can put that into a version-controlled system to stand up infrastructure. And that just helps you to build the tooling that you need. As far as the ML ops and DevOps side of things goes, knowing Kubeflow, Docker, subprocess, Conda. We were talking a little bit about like data stores for like the results of an ML model. Those can sometimes go into vector DBs when you need a feature store. Again, like just repeating the same like key value stores or document stores as needed. A lot of times the results of ML models is actually some form of graph. And so that's the reason in particular that vector databases have become so popular. The third and another flavor of data engineering that I've definitely seen a lot more of recently is the analytics engineer. This term was coined by DBT. And they're really focused on providing great analytics decision making, and they provide relevant and consistent insights for making those decisions internally and surfacing them into a BI tool of your choice. They provide just super high quality transformations, and they have a more consistent understanding of what the data in the data model is and how to join it to all those other contexts. They're usually the folks that are working more closely with finance stakeholders or analysts or other folks who are directly involved in that strategic decision making. Their skills include elite level SQL foo, in my opinion. They're usually the folks that know the OLAP database the best and the best way to make sure that things are performant with the SQL that they're leveraging. BI tooling familiarity, so that just depends on what your business has chosen as far as business intelligence tooling. It's usually Looker or Tableau. And then data visualization, minimal thresholds of like how do we represent this data in a snapshot to these external non-technical users in a way that they'll understand and be able to quickly make decisions on. And again, just the intimate knowledge of the data model. And so some example tools, frameworks to familiarize yourself with if this is the particular type of data engineering you're most interested in is just the business tool of choice. I put test superset on here as well. I know it's less popular, but if you're using Presto, that's usually like the thing that goes alongside that. And then transformations. So knowing DBT, having that SQL expertise, and at least like a basic knowledge of Python, if in case something is going wrong with the orchestration platform or with the ingestions that you're dealing in, it's nice to be able to at least be able to take a look at it, if not like report it to the data engineers that like, hey, something's wrong. Again, just being able to like empathize with each other and speak each other's language goes a long way across all of these various functions. Because this could either be one team, or these can be complete separate teams doing very highly specialized things depending on the business that you're in. So wait, I said nothing about ML or AI. That's very purposeful. When we talk about what goes into a model, these are the things that are going into that model. And if we have a dirty signal or noisy signal, it makes our models and our AI and our LLMs far less effective at figuring out the math of what comes next. Your predictions, your recommendations, your inferences are just not as viable because none of that has been contextualized in a clean, salient way. So a lot of the data engineering teams I have worked on talk a lot about how there's this concept of garbage in, garbage out, right? Like, if the signal coming in is not clean enough, I can't math my way into making that better. So while we want to invest in ML ops and data science and all of these places, if we don't invest in the layer underneath them, they can't do their jobs in a great fashion. If they're not getting great data, the quality of what's coming back out is just not as viable for your user and doesn't provide as delightful of an experience. So while we promised, like, what is the value of this towards your AI and ML, it's just a fundamental foundational layer to what goes in from there. So as an individual, like, what can I learn as a data engineer? Having spent almost 6 years doing data engineering, I can say first and foremost, you learn a lot of empathy across all fronts, technically and strategically, because you're just learning so much and you're working with such a diverse set of folks that you learn various perspectives and pain points. And not all of them are always on the same page, but we're all trying to be successful. We're all trying to figure out how to understand the artifact that's in front of me, despite what my own biases tell me about it. And then secondly, like, again, going back to, there's just such a wide exposure of what you're going to be doing between all the various interfaces that you're dealing in, alongside all of the various tooling that you've got. There's a wide range of opportunity for you as an individual to gain just technical breadth and knowledge, and like learn and create value along the way. As an organization, why invest in data engineering? This doesn't sound like any of the cool, fun, I'm going to use the word sexy here, things that come alongside AI or ML or LLMs. Why do this? Well, first, you can empower your organization to use data analyses to level up your own empathy and understanding of your users' journeys. For a long time, because I come from an English background, I used to say that this all pulled things together for me, because I started out taking fiction books apart and trying to weave them into a criticism or an understanding of what an author intended or what this character intended. And now, having been a data engineer for 6 years, the value of taking that same, like, piecing together different artifacts to understand folks, their journeys, their pain points, their the valuable things that we are providing for them or not, was like the first and foremost thing that came out of investing in this as an organization. Secondly, it just improves your strategic decision making when you can back up why you're making a decision with data and metrics. It's very tough for me now to make those calls for my team or for various, like, teams together without metrics. We can't just go on our intuitions alone. Providing more relevant user experiences through higher quality data models and connecting this back in to what your data science teams and ML teams are doing. And then lastly, this enables your application engineers, your product engineers, to build more data-intensive applications with a lower threshold to getting there. People really love being able to look at the insights that other products are giving them with their own data. It's hard to do that if you don't have that clean signal. So if you don't take anything else away from this talk, I will conclude this talk with this sentiment. One of my favorite metaphors from a previous manager was that data engineers are just the plumbers of the software world. We get data from point A to point B. And if any of y'all have rented a home or own a home, do you think about your plumbing day to day? Yeah, most folks don't. However, when gunk comes out of your taps, or you have a water issue, or there's some kind of water not happening for you, I guarantee you that is the day that you're going to want a plumber. And in this context, you are going to want a data engineer. Thank you all.